Hello friends, welcome back to my channel. I hope all of you are doing well. So guys, in today's video, I tried to cover most of the things that required to make this practical demo in Terraform successful. So in the end of this video, you'll definitely learn some very good concepts of Terraform. So let's start our today's video. So in today's video, firstly, we'll see how we can create Azure Service Principal and what actually service principal is and why we need it, because I have explained in my previous video also, but to make this video as complete end to end, I'm describing these things again. And once that is done, then I'll show you what is Azure app registration and client secret, and how we can create it and why we need to create it in order to create the service principal, because we'll use service principal of Azure in order to connect our Terraform to Azure cloud. And then we'll see how we can create Azure access control, because once we create service principal, then that service principal will not actually be able to do the thing. So we need to provide a role to this service principal so that this can actually do the configurations using Terraform configuration. It make things possible on cloud. So this is basically a kind of contributor role that we are going to assign in our today's practical demo. And once that is done, we'll understand what are the Terraform files and commands. So what basic commands that we need to use in order to complete this practical demo, so that I'll explain. There are multiple commands, but some commands use very frequently, so we'll discuss only those commands. And after that, we'll see a most important concept of Terraform, that is provisioners in Terraform. So provisioners, we'll see what provisioners actually is, but a brief description of provisioner is: once we create a virtual machine in Terraform by using Terraform configurations in cloud. So after that, if we need to do some kinds of configuration management, as I explained this in my very first or two slides or very first or two videos, that there is some difference between infrastructure as a code and configuration management. So Terraform can do a little bit of configuration management, and it is actually a champion of infrastructure as a code. So we'll today do the configuration management part that Terraform can do. And after that, as a configuration management, we'll install Docker and Kubernetes. So Docker installation is easy, but Kubernetes installation appears to be difficult. So in today's demo, we'll do that, and then we'll execute commands related to Docker and Kubernetes post creation of that VM by using Terraform. So we'll see everything in our practical demo. So let's start with the very first topic, that is Azure Service Principal introduction. So Azure Service Principal introduction we can see later, but if you are very new to this Terraform, so firstly you need to get to understand that how we can actually create this, or how we can actually install the Terraform. So firstly we need to go to Google and we can type Terraform installation for Windows, and we can go to the very first link that is highlighted as install Terraform. And after that we can go to this Windows option, and there we can select AMD 64 and we can press download option here. Once this is done, we'll see this kind of file on our system, so we can do an unzip of this zip file in order to install Terraform. So Terraform installation is not that much difficult as we see other softwares installation, but it is very simple. We just need to make the download of the binary, and then we need to set the path. So now the binary is downloaded in zip. Now it is extracted and it is unzipped. After that, this is basically the Terraform 1.7.0 Windows AMD 64 is the binary. Inside that we are having one application related to Terraform. So we actually need to make this Terraform, or to set an environment variable so that we can run Terraform command from anywhere. So what we'll do, we'll firstly go to environment variables. We can search in the search bar that is available in the bottom of the Windows screen. Then we can go to advanced tab, and there we can go for environment variables tab. Once we'll click on it, then we need to go to system variables, and there we need to select the path variable and then click on edit. And in the edit we can click on new, and there we can add the path where our Terraform binary is stored on our machine. So in my case it is somewhere in C drive, so I have given the complete path of that binary, and then we can click OK. And once that is done, then we can open the command prompt and we can run Terraform --version command. So this clears that now Terraform has been downloaded successfully. Along with that, it is working also successfully. So Terraform installation is done. Once this is done, now we are not using Notepad in our today's demo. So we'll use Visual Studio Code as an editor in our today's demo, because Visual Studio Code is having so many advantages, because it actually make readability very fast, and it also provides suggestion if we install some kind of extension in Visual Studio Code. So in Visual Studio Code, we'll install an extension of Terraform, so that we'll see the color coding related to Terraform. Along with that, if we'll type something, then an auto suggestion will also comes because of that extension. So how to install that Visual Studio Code? Firstly, we'll go to Google, and there we'll type Visual Studio Code download, and the very first option that we'll click on it. And here we are seeing installation related to Windows, Linux, Mac. So we'll go with Windows, and we can select this option. Once this is selected, it will get download to our machine, and we just need to do next. We don't need to make any modification over there. And once it is installed, we can go to the search menu, and there we can type Visual Studio Code. So this installation is very easy. Both installation is very easy, Visual Studio Code along with Terraform. And we can set it up so that we can type our Terraform configurations over there, and then we can execute commands. So once this is done, we'll see this kind of a screen, which is actually the Visual Studio Code dashboard. So we'll see this kind of a screen, and after that we'll open any folder where we are having configuration file. If we are not having, we can create a folder on our desktop, and then we can open by going to file menu. In this way, we can do our complete installation of Terraform. Along with that, we'll do the Visual Studio Code installation. Now comes to the topic, that is Azure Service Principal. So Azure Service Principal is basically combination of four things. So first is the subscription ID, and second is the tenant ID, third is the client ID, and fourth one is the client secret. So we need all these four parameters, and combination of this will give service principal. And in order to make connection with our Visual Studio Terraform to Azure cloud, we need to provide these four things, so that we'll be able to connect from this Terraform to Azure cloud, and will provision resources by using Terraform configuration files. So after that, how we'll get this subscription ID? So firstly, we need to go to subscription. So first of all, you need to create a free account on Azure. So you can create that free account. Once that free account has been created, then this kind of portal will comes in front of you, where you'll see an icon of this key, which is actually a subscription. So once you'll click on it, the next page will show you the subscription ID, so that you can take from there. And second is the tenant ID. So how to get that tenant ID? So we need to go to Azure Active Directory. Previously it was known as Azure Active Directory. Now it is known as Microsoft Entra ID. So once you'll go to portal, and you'll search with Microsoft Entra ID, you'll see this icon. Once you'll click on it, you will see client ID in front of you. So you can take it from there and note it somewhere. After that, we need to take client ID. So from where we'll take the client ID? So client ID and client secret, these are basically the username and password. So these actually not created on your portal by self. You need to firstly do an app registration. So how to do an app registration? Similarly, the way you did for subscription and Microsoft Entra ID, you can do for app registration also. If this icon is not coming in Azure services, you can search in the search bar, you will get it. Once we'll click on it, then we need to firstly go to new registration, and then we need to provide some name, just like I have provided test principal. And by default option, we can keep select as it is. As of now, we don't want to make a kind of single tenancy or multiple tenancy. We don't want to go in that much detail. So we'll go with the by default option, and we'll click on register. Once that is done, we'll see this kind of page. Once we'll go inside it, the test principal that we have created as an app registration. So we'll see client ID and tenant ID here also. So tenant ID, we can either take it from the Microsoft Entra ID, or if you don't want to get it, then you can take it from here also. So client ID is with you now, tenant ID is with you now, subscription ID is with you now. After that, you don't have client secret. So we need to actually generate client secret. So how we'll generate it? So firstly, we need to go to clients and secret, or sorry, certificates and secrets, that is available on the left hand side as a key icon. And once we'll click on it, then we need to click on new client certificate, or sorry, new client secret. And then we need to give some description, so we can give any name here, test or whatever of your choice. You can place it here, the text, and then you can click on add. Once that is done, you can see that one client secret has been created, which is having description test, expiry 7/20/2024. And after that you will have the value. So as of now I have removed those value because these all things are actually confidential, so these should not get shared with anyone. So that's why I have removed those things. But you will see the value at this place, and you need to copy by using this double file icon, and you need to get it copied right now once you created it, because if you will go from this screen and once you will come back, you will not be able to see this secret. So either you need to delete this secret and then you need to create a new secret. It is better once it is created, just copy it somewhere so that you can use it. So once this is done, we need to assign a role. As I told in my previous slide, that we need to assign a role to this service principal, because we are now ready with service principal. So we are having the subscription id, tenant id, client secret, but we need to assign some role so that it can execute the task. So for that, we'll firstly go to access control IAM. So where this option will be available, firstly we need to click on that, the very first icon I showed, that's a key icon for subscription. So once we'll go to that subscription, will land to this page. So here we'll see this access control IAM, and then we need to click on add. Once we'll click on add, we'll see three icons here. So firstly we need to select the add role assignment, and then we need to select privilege administrator roles, where we need to select this contributor role. So contributor role is actually the minimum role that is required in order to create resources. So the topmost role is the owner role, so we don't give anyone the owner role until unless it is actually mandatory to have that owner role. Because when we create certain resources, then most of the resources got created with contributor access, but there are some where we need owner access, where contributor access itself is not able to create the things. Then only we go with owner access, else contributor access is fine and we can go with it and to create certain resources on Azure. So once this is done, we can select member. In this select member, now we need to select the member which we want to add, and we want to assign this contributor role. So here we'll just search our what we can say app registration name here. So it was test principal, so just search it here, click it and select. Once this is select, just click on review and assign. Once you'll review and assign that particular screen, you'll get landed to this next screen where you are seeing this role assignments. So in this role assignment, you are seeing under privileged there is one. So it means one role assignment has been created for this test principal app registration. So now, and it is having the role contributor, and we are good with the service principal along with the role. Now we can proceed with the creation of the things. Okay, so once we are done, we'll create one folder on the desktop with a name test, or any name you can take it here, and then open the Visual Studio Code. So first time once you'll open any folder, it will give you this kind of warning. Do you trust the authors of the files in this folder? So you can simply click yes, I trust the authors. Once we are done, then we need to create certain files. So every files in Terraform will have a .tf extension. So either we can place everything in a single file, just like we can place uh, all the code in main.tf only, but it is better to segregate different things in different files, so that whenever we want to modify anything, then we can get it modified by editing only that file, and we don't want to get touch this main.tf, because main.tf is basically for having the complete resources which we need to create on Terraform. So we'll create two files, one is main.tf, one is provider.tf. So in main.tf we'll place the code in order to create resources on cloud, and in provider.tf we'll place the connection that will make using that service principal. So we'll place that connection inside it. So I'll show you what all connection related parameters is required. So I'll place those parameters and put the value of those parameters, but I'll not show you the value of those parameters, as I said earlier that it is actually confidential. So once we are done, we can create resources inside it. So just like we can create different kinds of resources, this is the example of one of the resources, which is very basic resource of Azure, that is resource group. So we can create a resource group by putting this particular code. So these all codes are available on Terraform registry. So I'm going to use a creation of virtual machine today. So there are multiple such resources required in order to create a virtual machine. So I'll copy those resources from one of the notepad, because in my previous video I have explained step by step how to get all those code from Terraform registry. So if I'll go with every resource copy and paste, then it will take much time and this video will become very long. So I don't want to make this videos that much long. That's why I'll proceed with a notepad and I'll copy each resource that is required in order to create the virtual machine. So once we are done, we firstly need to go to the registry.terraform.io, and there we can click on Azure Cloud Provider, so that we can get the complete connection string that we need to place in provider.tf file. So once we'll click on this Azure, on the right hand side we are seeing use provider. So we'll click on it, and inside that, this particular code is the code that is highlighted. We need to copy this complete code and we need to paste in our provider.tf file. So now in the provider.tf file we'll be having the complete code, and after that we are seeing that in the azure.rm file. If we'll go to the previous slide, so here we are seeing in the bottom provider Azure RM, and there is a hash option, configuration option. So configuration options are not mentioned here because we need to place service principal here. That's why they have just given its hash, because they are actually not mentioning that thing. But we are aware that we need to provide the subscription ID, tenant ID, client secret, which is basically a service principal. And after that we need to place a features block. So this block is having certain other features, but if we don't want any other feature, we can go with it a blank. So we'll only continue with our service principal and we'll keep it blank. So this will be our provider.tf file, which is also completed. And all these parameters from where we can get it from our cloud, and that I have already explained from which options you can get all these parameters. So once this is done, now let's proceed with certain commands that are very basic commands of Terraform, but very useful commands of Terraform. So first command that we'll see, it's a Terraform fmt. This command is basically to auto correct the format and style. So suppose if you have placed some spaces in some of your code, and if you'll write this command, then everything will self come to the alignment. So code will get aligned by self. We do not need to make anything change, just need to run this command and everything will get correct by itself. Second command that is important is Terraform validate command. So it will validate that whether the configurations that you have placed in your main.tf file for all the resources, whether the linking of all those resources are correct or not. If there is anything that, suppose you have placed some variable and you haven't assigned any value to that variable, then if you'll run this command, it will give you error at that step and it will ask you to provide some value. So in this way we can validate our complete configurations file using this single command. After that, the third command, the most important command, is Terraform init command. So this command basically download the provider related plugins, and as we have provided provider Azure RM, so it will actually download plugin related to Azure cloud. Once that is done, we need to write Terraform plan. So it is just kind of a dry run that it will run on our configuration. So it will not create any resource on the cloud. It will just give us a dry run that these all resources are going to be placed on cloud. And this is the blueprint kind of stuff. And if you want to continue, then you need to go with the next command, that is Terraform apply command. So once we'll do an apply, then it will ask for our approval whether you are yes or no. So firstly it will run a plan in apply also, and once you approve, then it will proceed to make all those changes on the cloud. So once everything get created on the cloud and we are done with everything, then we need to destroy also, because this is actually cost consuming. All the resources are actually having some cost behind, so we don't want to make anything, or we don't want to increase our bill on cloud. So that's why once we are done with the lab, then we'll destroy everything. So it will actually destroy whatever it has created on the cloud, and it will make use of one of the file, that is terraform.tf state file. Once we'll provide approval yes or no, then only it will proceed with the destruction process. So these are the commands which are certain commands in Terraform which actually we use, and there are other commands also, but these are the commands where 95 or more than 95% work is done with these commands. Okay, after that, once we run Terraform FMT, so we'll see the output will be just like this. So it will correct the file and then it will give us that what all file it has corrected. So here we can see main.tf and provider.tf has been corrected. So after Terraform FMT, we'll see another command, that is Terraform validate. So once we run it, we'll see this kind of message: success, the configuration is valid. It means all the referencing of the variables and everything is in place, so we don't need to modify anything, we are good. After that, there is a command, that is Terraform init. So once we run it, it actually download the plugins related to Azure. So as we can see that finding HashiCorp Azure RM version, everything, it will get download from there, and once it get download, it will perform a log file on that download. So once we get it download, it will create a folder .terraform, and it will also create one folder .terraform.log.scl, so that it will provide a log to those downloaded plugins. So from next time whenever we'll running, first it will check that particular file, and if version is the same, then it will proceed, else it will ask us to upgrade the version. So we'll see the file Terraform and Terraform log.scl, as we can see in screenshot that is highlighted. Similar files we'll see once we'll run it. Okay, so our next command is Terraform plan command. So once we'll run Terraform plan command, it will just show us that it is going to provision this particular resource group, and it is saying 1 to add, 0 to change, 0 to destroy. So this is a kind of plan which is a dry run, which is actually not get implemented on the cloud, just to give us what it is going to create. So once this is done, we can run a Terraform apply command. So there now it is asking for our approval. Do you want to perform these action? Firstly, it is performing plan, then it is performing the action that it is going to do, but not without our approval. So in the enter a value, we can either press yes or no, but if we will not place yes or anything else we are placing, then it will not approve, only yes will work here. So it will create two files once it is done. So firstly, it will create terraform.tf state file, and it will also provide a log to that file, because whenever Terraform do anything, just like it is performing creation of resources on cloud, it perform log to state file, so that any other user cannot do any kind of apply or destroy at the same time, because this particular file is logged. So this is a very good feature, so that multi operation is not allowed at the same time, else this tf state file will get corrupt. So in case of Terraform apply, suppose if we are running that command, then what will happen? Then it will create a one terraform.tf state file, as I have said, and it is saying that one resource has been added. So apply is basically concerned with this terraform.tf state file, and once it is getting applied, now we are not seeing any lock to this terraform.tf state file, because operation is completed. So similarly, there is a question in our mind. Suppose if we are running Terraform apply and accidentally we are running Terraform apply again, then what will happen? So in that case, Terraform is very smart. It will go to the terraform.tf state file, and it will check the desired configuration with the current configuration, and if everything is same, then it will say no changes, your infrastructure matches the configuration. So it is saying 0 added, 0 changed, 0 destroyed, means it is not going to do anything, because everything is getting matched with the Terraform state cloud, sorry, Terraform state file and your Azure cloud. So in that case also, firstly when we'll run that command again, it will take a backup of that terraform.tf state file first, and then it will get check it with the newly created file. So in this way it actually provides checking with this file. That's why this file is very important, and it plays a lock, because if this file get corrupted, then Terraform will not able to check anything from this file. Okay, once we are done with the Terraform apply and we are done with all our testing, then we can destroy these resources. So similarly, when we are doing apply, we can do destroy also. It will show us what all resource are going to destroy, and if we'll provide our approval as yes, then it will do the destruction piece, and similarly it will firstly create a lock to that tf state file, and it will take a backup first for that tf state file, and then it will perform its action. So similarly we can provide here a yes, as I told that we need to give some approval, and once we'll give yes, it will destroy the resources and it will update us that resource has been destroyed. And similarly we can see the file here terraform.tf state and backup, because backup always created whenever Terraform do any kind of modification in this file, and the same it will get checked with the terraform.tf state file. So old configuration are with backup and new configurations are with tf state file. So these were the some files and some commands that we are going to use in our today's example, and we'll create virtual machines. So as I told earlier in the slides that we need to create certain resources in order to provision a virtual machine in cloud. So what all resources needs to use in order to create a virtual machine in Azure cloud? So the very first resource that is requires the resource group. The second resource that we need is the virtual network. The third resource that is required is the sub network. The fourth resource that is required is public IP. The fifth resource that is required is network security group. The sixth resource that is required is network interface. The seventh resource that is required is association between this ASG, or what we can say NSG, that is network security group, and your network interface. And after that we'll go to the virtual machine resource, and virtual machine will be combination of all these resources, and our Azure virtual machine once created, then we can get it access using the public IP. So we can access it by using browser or from external world, what we can call it as internet. So we can access it using the public IP that we have created and assigned to this particular virtual machine. So now the new concept that comes into picture is the provisioners. So why we use provisioners? What are the provisioners in Terraform? So provisioners comes into picture once we are done with the creation of virtual machine. So now suppose your virtual machine has been created and you want to install certain kinds of software, you want to do anything post creation of that virtual machine. So that we can do with the help of provisioners. So provisioners is basically a concept that is provided in Terraform in order to execute something on that particular machine after creation of that machine, so which we actually called the configuration management. So just like in my earlier first two videos where I have discussed what is the difference between IAC and configuration management, so where I have given the example, just like you have purchased a laptop from market and after that you are installing certain software just like Notepad++, Acrobat Reader, so these kinds of software. So the machine that you have purchased from market is the virtual machine, so that we are creating using Terraform resources, and the software that we install on that machine is just like of configurations that we are doing on that machine, so that we'll do with the help of these provisioners. So firstly let's see how many types of provisioners we are having in Terraform. So there are three types of provisioners in Terraform. So is the first provisioners that we are having here is the file provisioner. The second provisioner that we are having here is the local exec provisioner, and the third provisioner that we are having here is the remote exec provisioner. So every provisioner is having its own functionality. So what file provisioner actually is, so when we want to copy a file from local machine to the newly created VM, that we can do with the help of this file provisioner. So what will be this file? Suppose if we want to install something and that installation is very big, that contains around 20 lines of code in order to get that install. So in order to execute individual command, better to place all the commands in a file, just copy that file and then execute that particular file. So firstly we'll write all the commands in a file which is called file provisioner. So by using file provisioner we'll copy that file, and once the machine get provisioned we'll place it to the certain location. So we need to provide source location and destination location. So the file provisioner is basically to copy a file from one location to another location. The second provisioner is the local exec provisioner. So now suppose a file provisioner has placed the file inside the machine. After that we want to execute that script, so that execution can be done by using these other two provisioners, that is a local exec provisioner or remote exec provisioner. So local exec provisioner is basically the provisioner that we need to execute anything not on the newly created machine, but from where we are running our Terraform command. So why we need it? We actually need it whenever we want to make any kind of API call. Suppose if your machine has been created and you want to send the IP address of this particular machine to certain other API. By using API, you want to get it sent to some other application. So that you can do by running a command. So that command will run as a local exec. It will take that IP from the configuration and then it will provide to the other application by using the API call. So that API call we can give using this local exec provisioner. And what is this remote exec provisioner? So this is the one that we are going to use in our today's example, because we don't want to execute the command on the machine from where we are running Terraform. Rather, we want to execute it on the VM that has been created using Terraform. So we'll use this remote exec provisioner. So in today's installation that we are going for Docker and Kubernetes, so it is not having much command. That's why we are not using file provisioner. We are directly using remote exec provisioner, and we'll see what all those commands in. And by using this remote provisioner as an example, we can see that it is basically for installation of certain kinds of software, or what we called in technical term, it is a configuration management using remote exec provisioner in Terraform. So once we need to invoke all these provisioner, first of all we need to place a connection block, because how our Terraform script will know that they need to perform certain action on that particular machine. So what we need to do, we need to place a connection block first, then we need to use the remote exec provisioner. So in connection block we need to give host, username, password, and then type. So we'll connect that particular host using SSH connection by using the username and password that has been provided. And in case of host, we need to use self object. So self means the machine where the previous command were getting running before creation of that virtual machine. Same we need to use, and we need to use public IP address of that particular machine. So by using self.public.ip.address, automatically it will take IP address of that newly created VM, and it will perform further action on that particular VM. So we need to place this connection block first, then we need to place remote exec provisioner after this connection block. So let's see how we can use file provisioner. So the syntax of file provisioner is just like this. In case of provisioner, we can write file, and then we can provide source and destination, from where we need to pick the file, from where we need to copy the file. Similarly, in case of local exec, we need to just change the name of the provisioner, that is local exec, instead of that file provisioner, and then we can give any command here. So this command will be running on the machine from where we are running Terraform commands. So just like in our example, we are running it from Windows machine. So once we'll run this command, it will execute on our local machine. But we don't want to get it used because we want to execute the command in the newly created VM. So that's why we'll use the third provisioner, that is remote exec provisioner. So this is the syntax of remote exec provisioner, where we'll use provisioner and the name of the remote exec, and in the inline we'll write all the commands that we actually need to run in order to install anything. So we can also use file provisioner with remote exec, as I told earlier, that suppose if we want to create some script first that is having around 20-25 lines of code, so we can place in a file, we can copy that file to the newly created VM. Suppose we have created Linux VM, so we can place script.sh file to /tmp/script.sh, and then we can use remote exec provision firstly to change the permission of that file. So we'll use chmod +x, so it is actually giving executable permission to that file, and then we can execute that script with the command /tmp script.sh, and if any argument needs to pass, that we can pass. So now it is very easy to do a kind of configuration management also along with the infrastructure as a code by using Terraform. So once we are done with this, now we are having the actual code that we are going to use in today's example in order to install the Docker and Kubernetes on the newly created VM. So we'll use this provisioner as a remote exec. Inside that we'll use an inline block, and is this inline block will firstly need to update the packages in that machine. Then we are installing curl command. Why we need curl command? Because in order to download anything, we can either use wget or we can use curl. So curl by default don't come in all the newly created VMs. So that's why we are installing it first. Then we are curling. So what we are doing with this curl, we are actually downloading the package of kubectl, because in order to execute commands on Kubernetes cluster, we need to use kubectl utility. So firstly, we'll get it download, we'll give it as an executable permission, and then we'll move it to user local bin so that we can run our kubectl command from the Kubernetes cluster. So firstly, we'll install kubectl utility. Once this is installed, then we'll run a command sudo apt-get install docker.io-by. So by using this command, we are installing Docker first, and then we are adding this particular user, whatever be the user of our machine. So I think we're going to use Azure user as an user of our machine. So we are adding that user to group Docker so that our user can execute the Docker command. So these two commands will work for Docker. And now we are going to install a cluster, or what we can say, we are going to install a minikube cluster, which is exact replica of Kubernetes. So we can do any kind of testing by using it, and its setup is also very easy. So if we want to do a kind of hands-on on one of the cluster of Kubernetes, so we can do it. So it's a single node cluster, so master and node will be the same on the same machine. So firstly, what we need to do, we need to get its binary download with the help of wget command. Once it get download, we need to give a execute permission on this particular exe, and once it get the executable permission, we need to move it to user local bin so that we can run minikube command from anywhere. And there is some prerequisite also, that we need to install conntrack. So we need to get it installed also. And one thing, get remember that the version of minikube cluster is very important to note here. We are installing v1.22.0, because if you install any latest version or any other version, maybe these command won't work. So better to use these commands so that your cluster will set up in a single step. If you are performing the same things along with me, then you'll not face any error. But if you'll change the version, then you might need to add certain dependencies or anything else. So I used this version 1.22.0, and I have used a dependency that is contract with it, and it worked fine. And then I have started this minikube cluster with a VM driver as none. So there is other option, just like we can go with Docker also. But for security purpose, it gives us a warning that better to go with none in order to make it secure. So we'll go it with the same. And then after that, I'm changing ownership of these two files, that is basically $user and $home. So $user is the user, that is our username, and home is the home directory of that user. And basically these .cube and .minikube file got created in the home directory post installation of minikube cluster. And if we'll not run this command, then every time we need to run sudo command with minikube and sudo command with kubectl, which we don't want to do. That's why we are changing ownership of this complete home directory along with user, with the with the ownership of the user that has been created on this particular machine. So what we are doing with it, that we are using chown-r $user. So it means that $user is Azure user. So just make the permission of these two directory, that is .cube and .minikube directory, which are present inside our home directory, with the permission or with the ownership of Azure user. If you'll not make this command, then it will make these two um, files, or what we can say, these two directory with root ownership. That's why you need to run sudo command every time. If you don't want to do it, you can just change the ownership to the machine user, so that you will run kubectl and minikube command. Rather, you need to use sudo command, or you need to use sudo as a parameter before these commands. So guys, these all were the slides which were actually pointing to the theory session only. And I'm now done with the theory piece. So hopefully you actually got what we are going to do in today's practical demo. But if you are not clear with the theory, then you don't need to get worry, because we'll do it practically, and once we'll do it practically, everything will get clear post completion of this practical. So now move it to the practical demo, and let's see how all these things work. Okay guys, so this is basically our Visual Studio dashboard, and I have installed Terraform, I have installed Visual Studio Code. So post installation of that, I have just created a folder Terraform demo. Inside this folder, what I did, I have just created three files, that is main.tf, output.tf, provider.tf. So I have just opened that folder and it is looking like this. So as of now, I haven't placed any code in main.tf, but I have placed the things related to connection in provider.tf. So I have placed service principal related parameters here. I'm not going to show you this particular file because this is confidential, and rest two file I'll show you what is going to place. So the main.tf, we are going to provision a particular machine, that is a Linux based machine. So what all resources are required that I have discussed in my slide, I'm going to create here. So I have just placed it on the notepad. So the very first resource that is required is the Azure RM resource group. So from where I have get this code and everything, I have a detailed video of step by step of a virtual machine creation or Linux virtual machine creation. So if you want step by step from where I have copied, so that you can see in there, I can show you only one block, that how I get it found on the internet. So we just need to type the thing that we want to create. So firstly we need to create a resource group. So we'll go to Google and here we'll type Azure RM and resource group. So once we'll click on it, then we'll get the Terraform registry related icon here, or the link here. We can go to this particular link and this is the code. So I copied it from here, and if you want any modification in name or location, that you can do. So in this way you can find out all the parameters, just like virtual network, subnetwork, everything is available in the documentation. I have copied it from there. I'm not copying each from that documentation as and because it will take so much time and video will get lengthy. So I'm just copying the first resource that I have discussed in my slide. So this is basically a resource group. So firstly we'll paste it here. So the resource group will get create with this particular code, and this portion was not there. So this is basically a tag that we want to give a kind of label to this resource group. So in this way you can give environment just like dev, test, prod, anything you can give. If you want to get it removed, you can copy it and can remove it. So it's on your choice whether you want to give any tag, or if you don't want to give, just remove these three lines. It will work perfectly. So now after resource group creation, we need to create a virtual network. So we'll copy virtual network code here. And once the VNet has been created, then we need to create a subnet. So we need to copy code for subnet and we'll paste it here. After that, we need to go to create a particular public IP. So we'll copy it and we'll place it here. So I'm using this hash, and the text after hash is coming in green. So this is basically a kind of comment that we can give. So in order to make readability, we are just giving a comment that this block is for public IP, this block is for subnet, so that anybody who is going to read this file can easily understand the code, that which block is related to which particular resource. After that, we're going to create this network security group. So network security group is nothing. Here we are just opening the port of this particular machine. So we are going to open 228044332323. So just like we need to open any number of port, we can place after separating comma. So in today's video we are going to open these ports. That's why I have given these four ports. And once we are done with the network security group rule, then we need to create a network interface, which is a kind of network interface card that actually in our laptop or in our desktop, this NIC card remains inside our machine. Similarly, when we create resource on cloud, this is also a kind of virtual machine. So we need to provide a network interface card. And once this network interface card resource has been created, we need to make a connection of the security group to this network interface card, or what we are saying, we want to open port for this particular network interface card. So we'll paste its code here, and once this code is placed for connection, we can now go with the virtual machines code. So in virtual machines code, as of now I'm not copying the connection block and the remote provisioning block, rather I'm just copying the code of virtual machine. So if you'll paste it here, there is one brace missing. So now that brace is also placed. So now we are done with the code that will found on the internet on Terraform Cloud documentation. So this code you will found in Terraform Cloud documentation. But the other two, connection block and the Remote-Exec block, that exactly you will not found, because that you have to create that what all commands you want to execute on that particular machine. So block you will be able to find, but you will not able to find the code that we need to execute. So in this way, now we are done with our complete code of creating a virtual machine. So in order to create firstly the connection block, we need to just leave the last brace as it is, and we need to place the connection block first. So we'll copy this connection block and we'll paste it here. After that, we just need to place our remote executor block. So that is basically the remote execution provisioner block. So we'll copy it, and last brace already we added, so we'll not copy this time. We'll copy it and we'll paste it here. So now we are done with our complete code. It is related to the creation of virtual machine. Along with that, it can also do installation of the software, just like we'll install Kubernetes and Docker on it. So we'll just save this file. Okay. And if you are not sure step by step, I tried to show, but if you want just step by step copying of the code also from the Terraform directory, so you just go with my previous video where I have explained step by step copying from copying code from the Terraform documentation along with that creation of the machine. So now we are good with it, and what we now have to do, we can go to this run tab, and here we can go with, not run tab, we can go with terminal, and here we can open a new terminal. So this terminal will give us the way where we can run the command. So that's why this is the beauty of Visual Studio Code, that we can code it here and we can run also. So firstly we'll run a command to check whether Terraform is there or not. So I think I have misspelled the Terraform spelling. So yes, Terraform is there and we are at dit directory. So firstly what we need to do, we firstly need to run a command, that is terraform init. So this command is the most basic command that we need to do in order to install all the providers, and after that we can run other commands also. So as we are now going to download, so we can see the file that I was discussing in the slide. .terraform file has been created, so it is actually downloading all the plugins in this particular folder. So once this will created, it will create one more file, that is .terraform lock.scl. So that has also been created, and it is now providing lock to this particular version of Terraform. So now we need to execute every time the code, it will check for this version. But if any other version is getting tried by the code, then it will give us the warning that that is not present in the .terraform folder. Either upgrade it or go with the v3.93.0 version. So we are good with the init part. Now we can execute a command, that is terraform fmt command. So it will format the files, what all files are present. So it is now formatting this main.tf and provider.tf configuration files. Once we are done with it, we can check whether the syntactically it is correct or not. So we can use terraform validate command. So it is saying success, the configuration is valid. So all referencing related to variables and the values, everything is perfectly, so we don't need to do anything. It is validated successfully. Once it is validated, we can go with the terraform plan command. So this is terraform plan command. Now we'll see that some other files will get created. One is terraform tfstate log.info. So that file just come for fraction of second because it is a kind of dry run. That's why that file got created and removed. So it is now saying to us that 8 resource is going to add, 0 to change, 0 to destroy, and all these resource are actually 8 resource from resource group to virtual machine. That's why it is showing 8 as to add. And now as we are good, we can go with terraform apply. So either we can write -- auto approve, it will not ask for approval, but we want that approval step, so we'll go with terraform apply. and if we'll give it yes, then these resources will start provisioning. So as we can see that it is connected to our Azure cloud and resource group creation is in progress, then virtual network, then public IP, then network security group. So all these resources will get create on the cloud. So this takes actually time because virtual machine itself take around 2 to 3 minutes, but we want to install that Kubernetes cluster also along with Docker. So it will take some time, but I'm not going to pause this video as of now. So till virtual machine creation, I'll not pause, but post that we'll see that whether connection is getting successful or not. And once that connection is successful, then we'll see whether it is going to perform those commands on the created VM or not. So guys, this is actually very important example because in industry also or in live projects, whenever you will work, you need to do certain these kinds of thing. That's why it is called that when you do Terraform related thing, then you need to be good in shell scripting also because you need to write certain commands in order to get it execute post creation of VM. So this is a small example that we are installing something, but there may be a situation where we want to install some SQL server on a particular created machine, or we want to install some heavy software. So SQL is that. So here what we can see that it is connecting to our remote host. We can see by using the host IP, the username and the password is mentioned here. It is trying to getting connect. So it is making certain connection. Once those connection get successfully done, then it will perform the commands that is written. So it is saying now that it is connected. So now it is executing the command. Firstly, it is downloading packaging for kubectl, then it will install Docker, then it will install the minikube cluster. So what we need to do, we need to wait for some time. So as of now, it is fetching resources for kubectl utility, which is actually kubectl utility to run commands on Kubernetes cluster. So we can see that it is going in good way. Curl is doing its thing. Curl is now manually installed, and we can see that it has now downloaded the package of kubectl, and now it is doing things related to Docker also. So it will take some time, so I don't want to make this video very long as it is doing the things. So let me pause this video, and once everything will get done, then we'll go and check whether everything has been successfully installed on that particular machine or not. Okay guys, so as of now we can see that it is installing kubelet. Still it is running, so it has taken 3 minutes 10 seconds. I just want to show you the files on the left side that terraform.tf state has been created, and it has performed lock on this file because as of now operation is in progress. So I'm going to pause this video again so that once this is completed we can continue. Okay guys, so we can see that now our minikube cluster has been set up. It is saying done. Kubectl is configured for minikube cluster also. We can see that 8 resource has been added, 0 change, 0 destroyed, and this is particular the IP of the VM that has been created. So we'll copy this IP and we'll see whether we are able to log in this particular machine or not, and whether we are able to access these three utility, that is kubectl, docker and minikube cluster accessible or not. So let's log into this particular VM. So this is taking some time. I think we are inside this VM now. So firstly we need to type uh, what we can say, it's docker version. So we can see that docker has been installed, and we can also see kubectl version. So kubectl is also installed. Now we can see minikube version. So minikube is also installed. So we can write certain commands, some simple commands of Kubernetes. So just like kubectl get nodes. So it is now connected to our master. So this is the control plane or the master plane that is having here or we can see like kubectl get nodes hyphen o wide. Okay, so now it is giving us the complete detail. So this is the docker related information, this is the kernel related information, OS image that we are using, internal IP that it is, what version of Kubernetes it is, and everything it is showing. So in this way we can do our hands-on on Kubernetes also, Docker also. But are you seeing how easy is this? In just what time it took, if it is mentioning here, so around 4 minutes, as I remember, it took around 4 to 4.5 minutes. And now everything is getting set up. Your VM is created on the cloud. Along with that, Docker has been installed and Kubernetes is also installed. And we can do any kind of practices related to this Kubernetes cluster. Just like if we want to check some kind of service, maybe if it is showing here, so yes, we can see that there is one service that is having of type cluster IP, and there are certain kinds of pod also. So if we'll say kubectl get pods hyphen n, I think it is cube hyphen system project where we are having those pod. So yes, we can see that we are having API server here, we are seeing a controller here, we are seeing kube proxy, kube scheduler, storage provisioner, etcd, core DNS, what all are the components of master in the node, because this is the master, this is the node, that's why we are having all components here. And we can also type a command that is minikube status, so that it can give us that kubelet is running, API server, kube config, and everything is running. So this is giving a clear overview that our Kubernetes cluster is working properly. Docker is installed here, and we successfully actually executed our practical demo related to Terraform, Docker, and Kubernetes. So guys, I hope now you are clear with everything whatever I was telling in my slides. So now everything we have seen in practical demo. So guys, if you like this video, just give a like to this video and please subscribe to my channel also, and I'll see you in my next video.